Hey guys, welcome back to my YouTube channel. Today I'm going to be showing you how to factor trinomials. So as with the name trinomials, right? Trinomials, tri means three, right? So here we have three terms, 1, 2, 3, okay? So we're trying to factor these trinomials, and the way I really like factoring these trinomials is, first I like to draw a box here and a box here, right, for this x squared. Then I like to draw a box here and a box here for this 18, okay, for this constant. So here in these boxes, I'm going to be writing in, okay, some either x or some constants, right? So what do these boxes represent? Well, here we know it's x squared, right? So we have to find two things that multiply together to give x squared. Now, x squared, we know that x squared is equal to x times x, right? So we could write in x times x, okay? So two things that multiply to give x squared, and also I would not put x squared and 1, like I wouldn't do this, like x squared and 1 in this box here and this box here. I would not do that. We ultimately want to factor it, so if we leave it as x squared, it's not really going to help us factor it. So it has to have x to the exponent of 1 and x to the exponent of 1, okay? So this x is the same as x to the exponent of 1. So that's why we can write that. And here 18, we have to find two factors that multiply to 18. So we could do 9 and 2. Okay, there's so many options. You can do 18 and 1. You can do 6 and 3, okay? And we must consider this positive sign, so those two have to multiply to positive 18, okay? We can even put some like negative numbers here, like negative 9 and negative 2, because negative 9 times negative 2 gives positive 18, as there is a negative here and a negative here. Two negatives make a positive. So we could do that. That's another option. There's so many options, like negative 1 and negative 18. Okay, you can even rewrite it like this, negative 18 on top and negative 1. So many options. So now we have all these options, right? All in boxes, and here we have negative 9x. So now we have to basically judge it based on this middle term, and we basically have to cross, okay? So we have to cross this over. So we have here x times 9, right? X times 9 here, and we have to cross this over. We have here x times 2, okay, and we have to add them together. So x times 9 plus x times 2 is the same as 9x plus 2x, and that gives us 11x. And is that equal to negative 9x? So we're trying to see, when we cross these over, if it's equal to negative 9x, and here it's not equal to negative 9x. So we can't use this one, and we can't use this one. Okay, so this is gone. Now let's try crossing it over with 18 and 1. Okay, so I'm going to cross it over. So x times 18. X times 18 is going to be 18x, right? And then here, x times 1 is going to be written here, okay, adding them together. So 18x plus 1 times x is going to be 19x. And 19x is not the same as negative 9x, it's not equal to that. So that means this doesn't work and this doesn't work. Okay, my diagram's getting messy. I'm just going to change the color of my pen. Alright, so I've changed my color of my pen, and here we're going to do the same step again. We're going to try this one. 6 times x, okay? 6 times x. So x times 6. And then here, we're going to try this one. 3 times x. 3 times x is going to be 3x, right? So it's x times 6, x times 3, okay? So 6x plus 3x, right? Because here we have 6 times x and x times 3, so like that. Wrote them here. And this is going to give us, what? It's going to give us 9x, but 9x is not equal to negative 9x. It's positive 9x, but it's very similar to negative 9x. So I wonder what would happen if, let's say, we made this negative, okay, and this negative. So negative 6 and negative 3, okay? Negative 6 and negative 3, right? Because we can try that out, because negative 6 times x is going to give negative 6x. Negative 3 times x is going to be negative 3x. And when we add those together, we're adding more negatives, so it's just going to give negative 9x. We can do that, right? So even so this didn't work, this gives us a hint, oh, we can just change the signs to negative, right? So this positive 9x is not equal to negative 9x, so obviously it didn't work, but it did tell us that we can change this to negative 6, okay, and negative 3, so we can basically get this, okay? And of course, negative 6 times negative 3, negative 6 times negative 3 gives us positive 18, which is found here, so that also works too. So since that works, we can basically test that. Okay, let's test that. So we have negative 6x, right, plus negative 3x. And why is that? Because we have negative 6 times x and x times negative 3. So we're going to try that out. And hey, we're adding more negatives, so we're going to get negative 9x. And that works. Okay, since this works, then that means we're going to circle this pair right here. And this right here. Right, so we're going to basically see that x minus 6 is going to be our first factor and x minus 3 is going to be our second factor. So if we factor it, x minus 6, right, is our first factor, x minus 3 is our second factor, right? So if we factor this expression, we are going to basically get x minus 6, as shown here, times x minus 3. So thus we can conclude that this expression, right, this expression, x squared minus 9x plus 18 is equal to x minus 6 times x minus 3. So now say we have a question that looks something like this, okay? We can apply the same strategy, but look at these big numbers, okay? It's not so fun dealing with these big numbers when it comes to factoring, right? Like using the same strategy I showed before. Instead here, we notice that we can factor out 8, right? Because all of these numbers are divisible by 8. So I'm going to factor out 8. So I'm going to write 8. So 8 times x squared gives 8x squared. And then we know, okay, well, if we factor out 8 here, we have to do 16x divided by 8. 16x divided by 8 is going to be 2x, because 8 times 2x gives 16x. And here we have negative 3, because negative 3 times 8 gives negative 24. So now we have factored it out. Now this is a little bit more easier to work with. So we're going to work with x squared plus 2x minus 3. So I'm going to copy it below, x squared plus 2x minus 3. And we're going to draw the same boxes as before. So x and x, and then here, well, we only know, like, basically if we just look at 3 by itself, like the absolute value of negative 3, we just know that 3 times 1 is going to give basically 3. That's like our own options, but we can manipulate the negative sign, right? So we have here negative sign, and we know we can manipulate it, right? Basically either negative 3 or 1, negative 1. So either 3 is negative or 1 is negative. So here we can, let's say, write negative 1, right? Okay, so let's test this out. So x times negative 1 is going to give negative x. 3 times x is going to give positive 3x. And what's going to happen is we add these like terms. Negative x plus 3x gives 2x And hey, this is positive 2x. It's the same as this middle term right here. So since it is the same, this works, okay? And since this works, that means we can do x plus 3 and x minus 1 as our factors. So it's going to be x plus 3 times x minus 1 as our factors here. So we have factored this part here, right? And it's basically the same as this part. We factored this part here, and we get the following. So I'm going to basically substitute this back in. So it's going to be equal to 8 times x plus 3 times x minus 1 from here, right? And so there we have it. We have factored this expression right here. Alright, so now for a question that looks something like this, right? We can't really factor anything out, okay, of all of these three terms. So from here, we're just going to start that method I showed before, making these boxes, right? So a box here, a box here, a box here, and a box here. So something times something has to give 14x squared. So the requirement is that they each have to have an x, okay? And so what gives 14 now? Well, we know that 7 times 2 gives 14. We can try 7 times 2. So I can write 7 times 2 like that, okay? And then here 20, we can find two numbers, right? Multiply together gives 20. So it could be, let's say, 5 and 4, right? Oh wait, but it's negative, so one of them has to be negative. So we could try, say, -5, right? We can do that. We can also do -4 and 5, right? Like that. We can also do 10 and 2. There's so many different options, but of course -10, right? And 2. Or you could do, you could also do -2 and 10. There's so many combinations, and then you just have to cross them with 7x and 2x. Oh, by the way, here, you don't have to be restricted by 7x and 2x. You can also write 2x and 7x, right? Like that. You can also write 14x and x, right? Just as long as each of these x's are to the exponent of 1, right? Because it's just x here, and so they're all each to the exponent of 1, like that. So yeah, so you can do that, okay? And you can also do x and 14x, okay? They're like basically like this. So there isn't only one option for this one as well. There could be lots of options. So you have to crisscross them, try them out. You can try, say, you can try this one, 7x. I'm just making a random one. Choosing a random one, 7x and -5. 7x times -5, so -5 times 7x, right, for this one. And then 2x times 4, so plus 2x times 4, and you will get -5 times 7 is -35 times x, just x right here, and then 2 times 4 is 8, so plus 8x. Now if you combine this, you will get -27x, okay? And this does not match up with 27x. It does not match up with this, so we cannot use this box and this box together. It's not to say that you have to cross off these boxes, right? Maybe these two boxes with this combination might work, right? You never know. So we can try that, like this with this, right? Can work. So you don't cross it off exactly, right? Before we crossed it off because there was only like pretty much one option for the x squared term, so that's why we crossed off the options from there, right? But here, it's not to say that you cross it off because you can do different combinations. Like now, we are going to be working on this combination right here, right? We're going to work on 7x times 4, as shown here in bold, 7x times 4, and 2x times -5 shown here in bold. So I'm going to write 7x times 4, 7x times 4, from here times here, 2x times -5, plus 2x times -5. So 7x times 4 is 28x. 2 times -5 is -10, and then there's the x, so put that in. 28x minus 10x is going to give 18x. Nope, this does not match up with the middle term, right? It does not match up with 27x, like positive 27x does not match up with that, so we can't use that. So we can't use these four, right? This type of combination. Now, how about if we try 2x times -4 and 5 times 7x. We can try that, okay? So what was the combination again? It was 2x times -4. I'm gonna write 2x times -4. 2x times -4 plus, right, 2x times -4, and then plus 7x times 5. So 7x times 5, and that's going to be equal to 2 times -4 is -8, so -8x. 7 times 5 is 35x, right? And 35x minus 8x is going to give us 27x. And hey, 27x is equal to this middle term right here, right? It's equal to this, okay? So hey, that works. And so since it works, right? Since this works, then that means this here and this here can help build our factors. By the way, when we used the boxes from before, when we did 2x times 4, right? You see this line, green line, thin green line, right? 2x times 4 and 7x times -5 as shown here. 7x times -5, 2x times 4. We got -27x. We could have judged it from here and been like, oh, -27x. Well, quite similar to 27x, the middle term, because it's just there's a negative here. So what we could have done is we could have looked from there and altered the sign. We could have made this positive, right? This -5 positive and made this a negative, just like we did here, and then altered it around. We could have played it with it like that. Like we could have did this. We could have made this positive and made this negative, because then if we do 2x times -4, we basically will have -8x, right? And then 7x times 5, right? 7x times 5 is going to be 35x. So 2x times -4 is going to be -8x. 7x times 5 is going to be 35x. And we could have gotten the same thing as well. 35 minus 8 is 27x, and we could have gotten this 27x as well, which also matches with this. And it's basically essentially, if we did that, we could have gotten the same factors, 2x plus 5 and 7x minus 4. Because here, if we basically look at this, if we looked at this with this, right, that's 7x minus 4, just like here, 7x minus 4, right? And then here, 2x plus 5, right, is the same as here. We would have gotten 2x plus 5, right? Because we would make a horizontal line here and underline it. This would be our factor. This would also be our factor. So writing that out, our factors are going to be basically what we have here underlined and highlighted. 7x minus 4, right, because these are circled. 7x minus 4 is that first factor. Our second factor is 2x plus 5, because this 5 has no sign, so it's positive. So 2x plus 5, just like that. So this is our factors of the following, right? So we can basically conclude that 14x squared plus 27x minus 20 is thus equal to 7x minus 4 times 2x plus 5. And there we have it factored. Alright guys, this is the end of my YouTube video. Thank you for watching. I hope it helped, and if so, feel free to give it a big thumbs up. And of course, I always love to know your thoughts about my YouTube videos, so feel free to leave a comment down below. I do read your comments, and furthermore, if you are new to my channel, feel free to hit that subscribe button. Anyways, I hope to see you next time for another math video. Bye!